discuss chapter 4 in class 10, that is carbon and its compounds. Let us first discuss what will be the learning objective, what all you will be able to explain. After studying this chapter, you will be able to explain the bonding in different carbon compounds. You will study and you will explain the versatile nature of carbon. You will also be able to differentiate between saturated and unsaturated hydrocarbons as well as the carbon compounds. You will be able to name organic compound and you will also be able to classify them on the basis of their functional groups. You will be able to write their IUPAC names. Then you will study the properties, chemical properties of organic compounds, and you will be able to explain the chemical properties of two carbon compounds. One is ethanol and the other is ethanoic acid, and you will be able to write the equations for the same. And last but not the least, you will be able to explain the cleansing action of soaps and detergents. So let us start this chapter. First, let us know what is the occurrence of carbon. You know, carbon, we write the symbol as C and its atomic number is 6 and its atomic mass is 12. So its electronic configuration is 2, 4. Though it's very meager in earth crust, the percentage is very, very low in earth crust and it is present as diamond and graphite. It is also present as the minerals, as carbonates and the bicarbonates in the earth crust. It is also present in water as a soluble carbon dioxide and also as the limestone. Then it is present in air as carbon dioxide. We all know that the percentage of carbon dioxide in air is 0.03%. Though its percentage in earth crust or air, it's very low, but carbon forms a very large number of compounds. We'll be studying it later. Why does carbon form large number of compounds? Let us see what is the bonding in carbon compounds. We have already studied about the ionic compounds, and we know ionic compounds have very high melting and boiling points. If we compare the melting points of ionic compounds with carbon compounds, we'll see that the melting point and the boiling point of carbon compounds are very low. It means carbon compounds are not made up of ions. So let us see first, let us try to understand why doesn't carbon form ions. As I said, carbon, its atomic number is 6, its electronic configuration is 2, 4. So to attain stability, it will either has to lose 4 electrons or it has to gain 4 electrons so that its outermost shell is complete. Let us see why doesn't it lose electrons. So if it loses all the 4 electrons, then it forms C4 plus ions. But as it has to lose 4 electrons, large amount of energy is required, which is not possible. That is why it does not form tetravalent cations. Let us see why doesn't it form anion. C4 minus ion, if it gains 4 electrons, then it will have 6 protons, but the number of electrons will reach now 10. So it is difficult for a nucleus with 6 protons to hold 10 electrons. That is why it does not form even the anion, tetravalent anion. So how does it complete its outermost shell and attains stability? So this is done by the sharing of electrons, and the bond which is formed by the sharing of electrons, we call it covalent bond, and the compound which are formed by the covalent bonding we call covalent compounds, or we call them the molecular compound. Before studying more about the carbon compounds, let us first understand what is covalent bonding. We'll take some simple example to understand covalent bonding. Let us see, we start with hydrogen, a non-metal. Whenever metal and non-metal they combine, then metals have a tendency to lose electrons and the non-metals gain electrons. And as a result, they form ions. So they result in the formation of ionic compounds. But if two non-metals combine, none can donate electrons. So they always complete their octet or they complete their outermost shell by sharing the electrons. We are starting with the simplest element, that is hydrogen. We all know hydrogen, the atomic number is 1. So It has only one electron in its K shell and it is unstable. Now to attain stability, it needs one more electron. So what it does, it shares one electron with the other hydrogen atom. Let us draw the electron dot picture for the formation of hydrogen molecule. So hydrogen with one valence electron we can show with its symbol, the valence electron only. This is called the electron dot picture. It is unstable. So it combines with other hydrogen having one more electron, and both of them they share one electron each, and the shared electrons remain with both the atoms. This way the two complete their duplet. But as they are sharing the electrons, they get chemically bonded and they form a bond which is called single covalent bond. So we can explain the single covalent bond is the bond which is formed by the sharing of one pair of electrons between the two atoms. This is the case. Then let us come to another non-metal, let it be oxygen. Let us see how does oxygen atom attain stability. The atomic number of oxygen is 8. Its electronic configuration is 2,6. It is 2 electrons short of the 8. So again, if oxygen atom is not combining with any other element, then oxygen atom being unstable will combine with the other oxygen atom and will be forming the molecule. So let us draw its electron dot picture. So as I said, with the symbol we draw only the electrons in the outermost shell. And as it needs 2 electrons to be shared, so we will be drawing the 2 electrons which it is sharing with the other atom towards the center, towards the other atom. So I am showing the other atom of oxygen. Again, it's 6 valence electrons out of this, which it shares only 2. This way we can draw the electron dot structure. The shared pair of electrons are with both the atoms and they get chemically bonded, but now they are sharing 2 pairs of electrons. Such a bond we call double covalent bond. So oxygen in its molecule forms a double covalent bond. Let us take another example of nitrogen. Again, nitrogen atom, its atomic number is 7. That is 2, 5. Again, it is unstable and it needs 3 electrons to complete its octet. Let us draw its electron dot structure. Again, as it has to share 3 electrons, so the 3 electrons I am drawing towards the center, and this is one atom which is unstable. To attain stability, it is combining with other nitrogen atom. So the 2 will be sharing the 3 electrons each. Means 3 pairs of electrons are shared by the 2 nitrogen atom and they get chemically bonded and they form a triple bond. Again, a triple bond which is formed by the sharing of 3 pairs of electrons between 2 atoms. So I hope you all have understood what is a single, double and triple covalent bond. This is, you all can see that there are some more examples given. Hydrogen atom and atom of fluorine, that is having 7 valence electrons, so they share only 1 electron each and forming a single bond. Then we can see the formation of carbon dioxide, where the 2 oxygen atoms will be sharing 2 electrons each with carbon atom, forming 2 double bonds with carbon atom. Then we can see the formation of methane, 1 carbon atom sharing 4 electrons, 1 each with 4 hydrogen atom, forming 4 single bonds. So this is the covalent bonding, and the particles so formed by the sharing of electrons we call molecule. Here are some more examples of covalent compounds. So methane, CH4. Then we can see another example, that is the next compound of carbon and hydrogen, that is ethane, C2H6. Again we can see the sharing of only 1 pair of electrons between the atoms. So it is also forming the single bonds only. Then let us understand. Just I gave a statement that carbon forms very large number of compounds. Actually, the number of carbon compounds outnumbers the compound formed by all other elements together. Let us find why does carbon form such a large number of compounds. So there are 2 properties of carbon which enables carbon to form large number of compounds. One is catenation and other is tetravalence. So what is catenation? Catenation is that carbon atom can join together to form large molecules. Large number of carbon atoms can join together to form large molecules. Carbon atoms can join together forming single. With these straight chains, they can join together in the branch chains. Even they can join together to form the rings. This property of linkage of carbon is called catenation. Then the atoms of other elements can join this skeleton of carbon atoms in a number of ways. So this gives rise to large number of compounds. Another property we call tetravalency. As the name suggests, its valency is 4. Carbon has 4 valence electrons. So it can form 4 bonds with the other carbon atom, or maybe that any other monovalent element, or maybe that nitrogen and oxygen. Again, this type of bonding may be in a number of different ways. So this also gives rise to large number of carbon compounds. So the two properties, catenation and tetravalency, they are responsible for large number of carbon compounds. Now let us study about the carbon compounds. We are starting with the simplest carbon compound, which are the compounds of carbon and hydrogen only. We call them hydrocarbons. As I said, they are the compounds of carbon and hydrogen. Now, again, depending on whether there is single bond between carbon and carbon atom or double or triple bond between carbon and carbon atom, they may be saturated hydrocarbons or they may be unsaturated hydrocarbons. So first we start with the saturated hydrocarbons. As I said, they have single covalent bond between carbon and carbon atom. The simplest hydrocarbon is methane. Carbon, as it's the compound of carbon and hydrogen only. So carbon forms 4 single bonds with other hydrogen atom, and this gives rise to the saturated hydrocarbons, which we also call alkanes. This is the simplest hydrocarbon. Then the second one will be having 2 carbon atoms, and the carbon atoms should join together by a single bond because it's a saturated hydrocarbon. So here you can see that the next one is C2H6, that is called ethane. Here children, I would like to add how do we name these hydrocarbons also. So actually all the hydrocarbons, they have 2 parts in their name. The first part in the name that tells about the number of carbon atoms in the compound. If the number of carbon atoms is 1, then we use the word meth. For 2, we use the word eth. For 3, we use the word prop. For 4, we use the word but. 5, we use the word pent. 6, hex, so on and so on. Now, if there is a single bond between carbon and carbon atom, then the ending, the second part, will be in. As I said, these compounds are called alkanes. So the next part will be in. So carbon compound, hydrocarbon with single carbon atom becomes methane. Its name is methane. Same way, this carbon compound, hydrocarbon with 2 carbon atoms, eth and then A, its name is ethane. Now let us study about the unsaturated hydrocarbons. Unsaturated hydrocarbons, again we have double bond or we have triple bond between carbon and carbon atom. Now if there is a double bond, the ending group is ene, and such compounds we call alkenes. And if there is a triple bond between carbon and carbon, then we call the compound the alkynes. And the ending which we use here is -. So this way you will understand the nomenclature of hydrocarbons also. So let us see the simplest alkene first. Now there should be a double bond between carbon and carbon atom. So there is no such member which is having only 1 carbon atom. So the simplest alkene will have 2 carbon atoms, and as you know, carbon always forms 4 bonds in its compound. So the other two bonds of each carbon atom will be satisfied with hydrogen. So the formula of this compound becomes C2H4, and as there is a double bond, so name of this compound will be, for two carbon atoms, eth and ene. So we call it ethene. Same way I can draw for the next member also. Only one carbon atom will have a double bond. So you can draw its structure this way. The remaining bond carbon will be completing with hydrogen. So this is propene. Same way I can just take some examples of unsaturated hydrocarbon which is having a triple bond. So first one member, again there should be a triple bond between carbon and carbon. And now you all can name this carbon compound. It is two carbon atom, eth and ine. So the name becomes ethyne. Same way you can draw the another member, the second member also. But here it will be, here you can see this carbon atom has completed 4 bonding, and for this it is completing, and this becomes propane. So these are the saturated and unsaturated hydrocarbons. Moreover, we can write a general formula also for alkanes. The general formula becomes CnH2n plus 2. As we wrote CH4, then the C2H6. So we can see here the N tells the number of carbon atoms. So if we double, to find the number of hydrogen atom, if we double the number of carbon atoms and add 2 to that, we get the number of hydrogen atom. So if we see this formula, we find any hydrocarbon which is having the hydrogen atoms which are 2 more than the double of the carbon atoms, then it will always be alkane, and we will be using the alkane ending there. Here the general formula for alkene is CnH2n. Here you can see the number of carbon atoms here is just double. The number of hydrogen atoms are double the number of carbon atoms. And for alkyne it becomes CnH2n minus 2. Here the formula for this is C2H2. We call it ethyne, and here it is C3H4. So this is, again you can see the number of hydrogen atom is 2 less than the double of the carbon atoms. So this is all about the hydrocarbons. Now if we see for butane, butane will be, as I told you, but word comes for 4 carbon atoms, and 8 is here, it means it's a saturated hydrocarbon. So C4 and the number double and plus 2. So this becomes C4H10. Let us write the structural formula for this. So I can write their carbon atoms may be, all the 4 carbon atoms may be a straight chain. There is one more structure possible where one of the carbon atoms may be in the side chain. Right? I may complete it CH3, this becomes CH2, this is again CH2, CH3. Here you can count the number of hydrogen atom, it comes 10. Again here it will be CH3, 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 and there will be one H with this middle hydrogen. Again you can see molecular formula of both the compounds is same, that is C4H10, but their structural formulae are different. Such compounds we call isomers. So I have drawn the 2 isomers of butane. One is, this is called normal butane, and this is called isobutane. We can draw the structural isomers for other carbon compounds also. The thing we have to keep in mind, their molecular formula should be same, but their structural formula will be different. So as for pentane, we can draw 3 structural isomers. All of you can see that first one is normal pentane, then you can see the isopentane, which is having only 1 carbon atom in side chain, and then you can have neopentane, where you can see there are 2 carbon atoms in side chain at the central carbon atom. Then this was all about the hydrocarbons, which were the compounds of carbon and hydrogen only, but carbon combines with the atom of other elements also. So when any other atom like oxygen, nitrogen, any chlorine atom, bromine atom, halogens, they combine with carbon compound, they impart the special properties to that carbon compound irrespective of the number of carbon atoms. Such atoms or the group of atoms we call the functional group. So let us study about the functional groups. They may be that OH, first may be halide, any halogen. It may be chloro, it may be bromo, it may be iodine. So while naming, if suppose any hydrogen of alkane is substituted by chlorine atom, we will be always the halide will be first, its name will be taken and then we'll be telling the name of the parent hydrocarbon. So name becomes chloromethane. Right? Next maybe the same way it is iodomethane if it is CH3I. Now functional group may be alcohol, it may be OH. Where this bonding is with carbon atom. So let us take one example, CH3OH. Now how do we name alcohols? Whatever is the name of the parent hydrocarbon, we remove E and then we add OL. OL ending is used. So the name of this becomes, it was CH with one carbon atom, the alkane was methane. So we write methane, we remove its E and its place we write OL. So the name of this compound becomes methanol. Same way we come for the next one, aldehyde, that is CHO. Right? I am taking one example, let it be SCHO. Is one carbon atom and the other hydrogen atoms have been replaced by the oxygen. So here again for one, the ending which is used here is Al. So the name of this compound becomes again methane, remove E and add L. So it becomes methanol. Next is carboxylic group, COH group is carboxylic group. If I write CH3COOH, the ending which is used here is oic acid. Again you have to count the number of carbon atoms. Here are 2 carbon atoms. So the parent hydrocarbon is ethane and again you will be removing E and will be adding oic acid. So ethanoic acid. The compound becomes ethanoic acid. Then is ketone. Actually this carbon of ketone will be joined to other 2 carbon atoms. So ketone group cannot be at the end. It will always be in between the carbon atoms. Right? So ketone we write it as its ending is on. So let us take one example. The simplest ketone will be CH3COCH3 and there are 3 carbon atoms and we know for alkane with 3 carbon atoms is propane. So we have to remove E and have to add on. So it becomes propane. No. Right? This way, these are the functional groups, the atoms or the groups of atoms which will now be giving the special properties to the carbon compound. As I am taking one example. Let it be alcohol. The simplest alcohol will be having 1 carbon atom. So methane and from methane, 1 hydrogen atom has been replaced by OH group. Then second one, this is name will be methanol, then is ethanol, then will be propanol, so on and so on. Right? So here this family of carbon compounds where the hydrogen atom has been replaced by the same functional group which shows similar chemical properties. They will be showing different physical properties. Such a family of carbon compounds we call homologous series. Right? Here they are having a different number of carbon atoms, but they all have hydroxyl group as the functional group, so they all show similar chemical properties. Right? Here we can just their physical properties are different, their densities will be different, their masses will be different, melting boiling point will be different, but they will be showing similar chemical properties. Right? So this forms one homologous series. Same way aldehydes will be forming another homologous series, alkanes will be forming another homologous series. Here we can see the characteristic of homologous series. We can see the successive member. If we see the difference in carbon and hydrogen atom, you will find the next member has 1 more carbon and 2 hydrogen atoms. So for the previous member, if I add 1 carbon atom and 2 hydrogen atoms, I may get the formula of the next homolog of that series. So this is all about the homologous series. As I said, alkenes will be having ethene, propene, butene, pentene. These is a double bond present, so they all show similar chemical properties and they will be showing similar chemical, they will be having the different physical properties. Same way alkynes will be forming a different homologous series having a triple bond there showing similar chemical properties. Now we come to the chemical properties of carbon compounds. The first one is combustion, that is complete oxidation. Whenever a carbon compound, especially whenever a hydrocarbon bonds in air, it combines with oxygen, carbon gets oxidized to carbon dioxide, water and hydrogen gets oxidized to water, and large amount of heat is given out. That is the reason that all carbon compounds are used as a fuel, because when they bond, they produce large quantity of heat. Another is oxidation. Oxidation, if we carry out oxidation with any specific oxidizing agent, as alkaline potassium permanganate can be used as the oxidizing agent. It may be acidified potassium dichromate. So especially this we study in case of alcohol. So when ethanol, that is C2H5OH, when it is heated with alkaline potassium permanganate, oxygen gets added to it, number of carbon atoms remains the same, but extra oxygen, that is we call the gain of oxygen, we call oxidation, and this results in the formation of ethanoic acid. Then the another is addition reaction. Addition reaction is the characteristic property of all unsaturated hydrocarbons. If I take one example, let it be ethene, C2H4. It's I can write it as, so when it is heated with hydrogen, or hydrogen is passed in the presence of nickel, now the addition of hydrogen takes place across the double bond and it results in the formation of a saturated hydrocarbon, that is ethane. Ethane changes to ethane. Such a reaction in which a molecule gets added across a double bond or a triple bond, we call addition reaction, and as I told you that unsaturated carbon compounds undergo addition. And this particular addition of hydrogen we call hydrogenation, and which is used to prepare vanaspati ghee from the vegetable oil. Another is if unsaturated hydrocarbons are reactive because of the presence of double and the triple bond, right? Whereas saturated hydrocarbons are very less reactive, they undergo only substitution reaction. As I take one example, methane, when it is exposed, when chlorine is passed in the presence of sunlight, then one of the hydrogen atom gets replaced by chlorine atom. It does not get added, it gets replaced. This will be forming CH3Cl. Such a reaction we call substitution reaction, and saturated carbon compounds undergo substitution reaction. Now we will study about two carbon compounds, the important carbon compounds. One is ethanol and other is ethanoic acid. Ethanol, its formula is C2H5OH. It is normally called alcohol. It has got a number of properties. It is a colorless liquid and it has a pleasant smell and it has burning taste. It is soluble in water in all proportion. You go on adding water, it will go on dissolving more and more water. Then it's about its chemical properties. It just simply reacts with sodium and it produces sodium ethoxide and hydrogen gas is given. We can balance this equation later. It also, there is one more important chemical reaction. How can we obtain ethene from alcohol? This is its reaction with concentrated sulfuric acid. So ethanol, when it is heated with concentrated sulfuric acid, which actually removes water molecule from it and results in the formation of C2H4, that is ethene. So concentrated sulfuric acid acts as a dehydrating agent here. It removes water molecule from alcohol. So These are the two important properties, two chemical reactions of ethanol. One is reaction with sodium and one other is reaction with sulfuric acid. One more reaction is there with carboxylic acid, which will be studied later. Based on its properties, it is used in all types of alcoholic drinks. It is used as a solvent. It is an excellent solvent, and in industries it is supplied as a solvent, but the laborers there, they misuse it. So that is why it is made poisonous by adding methyl alcohol to it, which is poisonous, and this we call methylated spirit, which should not be consumed. Then it is also used in medicines. All cough syrups, they contain alcohol. Now we come to the another carbon compound, that is ethanoic acid. Ethanoic acid commonly is called acetic acid. Its formula is CH3COH. It's a mild acid, it's an organic acid, so it shows all the properties of acid. It turns blue litmus pad, it reacts with metal carbonates to produce carbon dioxide gas, it reacts with base to produce salt and water, it also reacts with metal bicarbonates to produce carbon dioxide. So it will be showing all the properties which are shown by the acid, but it's a mild acid. It just ionizes feebly in water, will be producing less number of hydrogen ions. Now let us study its chemical properties. Important reactions. One is esterification. When ethanoic acid reacts with ethanol or an allycarboxylic acid, reacts with an alcohol in the presence of concentrated sulfuric acid, it results in the formation of sweet smelling substance which we call an ester. This process is called esterification. Then the reverse of this is hydrolysis, which may be done by using an acid or maybe by a base. The hydrolysis which is carried out using a base is called saponification, because just see, if I take this ester and it reacts with a base, let it be sodium hydroxide, it will be forming the parent alcohol, that is C2H5OH, but it will be forming the sodium salt of carboxylic acid. Actually, this process is called saponification because this reaction is used in the formation of soaps. Soaps are the sodium salts of higher carboxylic acid. This is saponification. As the remaining properties, chemical properties, I have already discussed with you, that it undergoes reaction with a base forming salt and water, and then with the metal carbonates or the bicarbonates. Now, as I discussed with you, this process is called saponification. So the important compounds of carbon are soaps and detergents also. Let us study about soaps and detergents. Soaps first. What are soaps? As I said, these are the sodium or the potassium salts of long chain carboxylic acid. The carboxylic acid which are having the number of carbon atoms more than 15. So those are called salts. Now let us understand the cleansing action of soap. I am taking one example of the soap. Let it be C17H35 COO, and this is a soap. The carboxylic acid is having 17 carbon atoms in it. Here the soap has been cleansing. You know, oil does not dissolve in water. If you put oil in water, you will find that they get separated, and all kind of dirt is oily in nature. So we can't remove the dirt by water. So what do we use? We either use soaps or we use detergents. Actually, soaps make a bridge between the oily dirt and water and help in the removal. So let us understand how does soap help in removal. So it has, this is the ionic end of soap which dissolves in water, and this is the carbon chain which will dissolve in any organic solvent or will dissolve in with the other carbon chain. So molecules, they have two parts, the ionic head and the long carbon tail. When we put soap in water, all of you can look at the diagram. So what happens? Ionic end, let this be the ionic head and this be the carbon chain of soap. So the ionic end dissolves in water this way, and the carbon chain, they don't have any other organic solvent here, so they dissolve in each other this way. They get oriented in a spherical structure. Such spherical structures we call micelles. So a number of such micelles are formed in water when soap is dissolved. That is why soap forms a colloid with water. What happens when we add dirty clothes to it? Now dirt, as I said, it's oily in nature. So all of you can see the other diagram here. Now let this be the dirt. Now this. So now the carbon chain, they all will dissolve in this oily dirt. They'll come again, the orientation will change and the carbon chain will dissolve in the oily dirt, whereas the ionic end will remain in water. So what has happened? Here you can see this is water. Again, there will be a number of such micelles in the soap solution. So this way, these soap solution, they are holding the oily dirt at the center and the other end is still in water. So they bring the oily dirt into the water. And when we scrub it or we beat it, what happens? Along with the water, then this oily dirt comes out, and this way the clothes get clean. Here you can see. Then the another family which is used, the carbon compounds which are used for cleansing, we call them detergents. Detergents are the sodium or potassium salts of sulfonic acids. Actually, soaps do not work in hard water because hard water contains calcium and magnesium salts. So when soap is used in hard water, they form calcium salt or the magnesium salts of the carboxylic acid, which are insoluble and get separated as scum, white precipitate, and lots of soap is wasted. So that is why soap cannot be used in hard water, whereas detergents, they are sodium, they are magnesium and calcium salts. They are also soluble in water, so detergent can be used in hard water also. The only problem with detergents is that they are non-biodegradable, so they pollute air. Soaps are biodegradable. So this is the difference between the soaps and detergents. And cleansing action of detergents is better than the soaps. So let us now summarize what all we have studied in this chapter. As I told you, you have studied carbon compound, you have studied about the covalent bonding, single, double and triple covalent bonding, then the versatile nature of carbon, how it forms large number of compounds because of catenation, tetravalency. Then we have studied about the IUPAC nomenclature, we have studied about the homologous series, and then we have studied about the hydrocarbons, also saturated as well as unsaturated hydrocarbons. We have studied about some carbon compounds. We have studied about alcohol, ethanol, alcohol, that is ethanol, and ethanoic acid, soaps and bitters. Thank you, children.